Hey guys, welcome back to SaxSQL. This is Ferry, and today we start our series on databases and SQL. So what can you expect? I will make 3 to 5 minute videos for the next few weeks discussing the fundamentals of databases in general and the concepts, techniques and tools used to design, maintain and access databases, and that includes of course the SQL or SQL retrieval language. We will do this at a beginner's level. So the first video today will focus on what is a database, why do we use it, and the basic concepts that come into play when discussing databases. So have fun, and I'll be back with you using the whiteboard for some conceptual discussion. Welcome to SaxSQL.
Hi, this is Ferry, your data expert. Welcome to SaxSQL.
Hello guys, welcome to the first video in this series on databases and SQL. As previously announced, we will keep this beginners friendly, so the videos will start from scratch. So today we will dive into what is a database and what is data in general, and why do databases play such an important role in software solutions. So as I've announced before, you don't need to have any prerequisite knowledge to follow these videos, and also these videos will be bite-sized, which means that we will aim to keep these videos short, between 3 and 5 minutes, and we discuss one topic per video. And the main question for today will be, what is data and what is a database? Those questions are actually harder to answer than you might think. One of the issues is that the term data is a container word. It can mean a lot of things, but within computer science, it's very important that you make sure that you don't have any ambiguous meaning towards frequently used terms like data. So we need to define that very precisely. I share my little whiteboard here. I have a pen here I can draw with. So let's discuss a few of these concepts. So data in general is hard to define in terms of a one sentence that meets the exact definition. Data is technically any raw fact or raw property of objects that exist in the real world. Now, that doesn't really help. It's a term that technically is defined within other terms, so that might only complicate things. So it's better to work by example. So my main definition of data is all the things you can write down in a list is considered data. So for example, you have, of course, letters and words referring to objects in the real world. Let's write a few things down, like cat. Not sure exactly why this doesn't work. Cat. And dog. And the word computer science as an abbreviation, or the number 6, the number 9, or an exclamation mark, or even a smiley, like this. All this on the screen is considered data through the eyes of a computer scientist. And you might ask yourself, yeah, but hold on, how is that possible? Well, first of all, everything is made out of characters. And as a computer scientist, characters are defined as technically symbols that are represented by one stroke of the pen, as you can see. Within the computer, all these characters are stored in a system called binary. Technically, everything you store inside a computer is made out of zeros and ones, and a computer can only understand zeros and ones. Now, and because everything is binary, that means that the computer needs to find a way to represent all these characters that we know as humans within computer memory. So we need to store a C, we need to store an A, we need to store a T, but we also need to store that exclamation mark and the smiley. And we can only do that by means of using zeros and ones. Now, I will do a series on binary and number system as well, but that is beyond the scope of this particular series on databases and SQL. So why is this all data? Let's see what we have here. Any word like cat or dog, or even the abbreviation CS, computer science, references an object in reality. So technically you can say, well, the three letter CAT, pronounced cat, reference an object in reality, like a physical cat walking around in your garden, for example. The same for a dog or a CS, or the numbers 6 and 9, which can point to any quantity in reality. For example, you go to the supermarket and somebody points at apples and you ask the clerk to put 6 apples in the bag. That number 6 is then a reference to a quantity that exists in reality. Hence, 6 apples in the bag, or 5 fingers on your hand, or 5 fingers on your feet. Sorry, not fingers, toes, of course. All these are human-made concepts. A computer doesn't understand this. A computer doesn't understand what a cat, a dog, 6 or 9, or even a smiley even means. So you need to find a way to translate concepts in the real world to a format that a computer can understand. And that needs to be done in the language that a computer speaks, which is binary. That is a language only made up of zeros and ones, as I said before. And this makes it very, very hard, because everything you see on the screen now, that needs to be stored in zeros and ones. Need to be represented in zeros and ones. Now, we are not going to dive in further in how that representation in binary works, but one of the things we can already conclude here is that, for example, to a computer, the word cat is comprised of 3 characters, C-A-T. And these 3 characters need to be stored inside the computer. The same goes for dog, CS, 6 or 9, an exclamation mark, and this smiley. To a computer, a number 6, an exclamation mark, a smiley, or the letter D is treated in a similar way. It's for a computer, it's all zeros and ones. So for humans, we will say, well, one is a letter, one is a number, and the other one is a smiley or an emoticon. For a computer, that has no meaning. It's all data. It's all meaningless. And that is also the essence of data. The word CAT has only meaning to English speakers. The smiley has only meaning to people that can recognize a human emotion, happiness. So that means that data itself, without any context, has no meaning. The same goes for numbers. The number 9 has no meaning in itself. If I walk up to somebody and I say 9, then a person will look at me if I have fallen on my head. The number 9 needs to be used in the context of a quantity in reality. For example, 9 what? 9 bananas, 9 cats, 9 people, 9 courses you take in university. Once you add context, then data becomes information. Information is technically dependent on the interpretation that people give to the data and can use that data to make a decision, because data was turned into information. For example, if I give you a random bunch of numbers, then you will say, what does that even mean? But if I give you the same random bunch of numbers, and I say, well, this is, in this sequence, these numbers represent the phone number of your dentist, then you would say, that makes sense to me. At that moment in time, all the numbers will technically turn into information for you, because you can make the decision to call your dentist and to have your teeth checked out. A computer has no interest in information or meaning. That's all done by humans. Humans use computers, so the main concern within computer science and people that design and build software systems, including databases, which are always an integral part of software design, at least 9 out of 10 times. That means that you need to interpret everything as data as a software designer. So cat, dog, computer science, 6, 9, exclamation mark and smiley is all data. No meaning is attached to it, at least not in the first stage. So yeah, what is data then? Well, pictures are data, audio files are data, words are data, phrases are data, alineas of text are data, paragraphs are data. Everything you can put in a list is data. That includes visuals and audio and video files, because at the lowest levels, a computer stores all this data in zeros and ones, better known as bytes, made out of bits. Every bit represents a state in a computer. Either something is on or off, 0 off, 1 on. The metaphor of the light switch. It has to do with electrical currents. Computer, of course, works based on electricity, and you either have a current or you don't. I will talk about that a bit later, but for now that is not that interesting. So to go back to the definition, what do we need when we talk about databases and storing data? Well, the most important is that we first find a way to how to store data physically. So technically that means, like, how do I make sure that, for example, if I enter my my personal data into a computer system, that the computer can literally retain that data for future access, right? Well, there's a few challenges then, and the first thing that is actually going on here is, and let me just delete this really quick and draw a bit of a different diagram to make sure that you understand what is going on. Alright guys, second part in the second video, which will be released at the same time. This was a lesson on data, and the next one will discuss the architecture of a database. Okay, see you over there. Bye bye.
Thanks for watching. Check my other videos to master your data.